Okay, so today we're doing finding limits algebraically. So finding a limit without using your calculator will be the next chunk of this chapter. So first here, look at this and try and decide where does the limit of the function equal the actual value of the function. So the answer to this is everywhere except these discontinuities. So all of this and this and this and this. So anywhere that you can pick the point, find the value of the function, and both sides come to that same thing, you're going to get the same limit and the same value. So that's where this note is. So if a function is continuous and defined at a value, then the value of the limit is the same as the value of the function, and you get the same thing. So you can use this to solve some limits just by substituting in whatever the number is. So if you're looking at like when x approaches 2, plug in 2, and that's the value of your function, as long as you're not like dividing by 0 or having an asymptote or something. So take a second and go through these. Which ones can you solve by substitution and which ones can't you? Okay, so this one, and this one you can't, and these 3 you can. This one you can't because you divide by 0. And here you can't do this one because if you plug in -2, you get the square root of -3, which is not possible. And then this one you'd end up with 1 over 0, which is also not possible. Here, sine of 0 is 1, cosine of 0, pause. Sine of 0 is 0, cosine of 0 is 1, so this one would just be 0 and it works just fine. Here, if we plug it in, you get square root of +3, so that works just fine. And here, if you plug in 2, you're going to get +1 on the bottom, so it works just fine. All right, so finding this limit. So right off the bat, you can't just plug in 1 because then you get 0 on the bottom. So try and manipulate this somehow, see if you can change it so you get to that point. So what can you do with this? We can factor the bottom. So you have x minus 1 on top, x plus 1, x minus 1 on the bottom. These are going to cancel. And you get 1 over x plus 1 here, and then we can plug in 1 to get 1 plus 1, or a half. So the limit is just a half. A note here, looking at this, what's missing? So what's missing is these operations aren't carried through. So we should have a plus here, a minus here, and a minus here to then get 0. It's the same idea with the limit. So you need to write the limit as x approaches whatever your number is all the way through until you plug in your number. So back here, you need your limit here and here because I hadn't plugged in 1 yet. But once we get to this point, you don't need it anymore because I plugged in 1. So you need to write the limit until you plug in your x value or your a. So that's what this slide is saying. So just like an operation or like adding and subtracting, you need to have them there until you actually do that. So until you plug in 1, so when we plugged in 1, that's when you can get rid of writing the limit. If you don't write the limit, points will be taken off the test, just as like a heads up. Okay, so finding this limit, start off, I'm going to FOIL this out because I can't really do much at this point. So we have our limit as x approaches 0, FOIL it out, and you'll get 9 plus 6h plus h squared minus 9 all over h. So then the 9's will cancel, and we have 6h plus h squared all over h. Then I'm going to factor an h out. So h on the outside, 6 plus h on the inside, h here. These h's will cancel. Limit as x approaches 0 of 6 plus h. And now I don't have an h on the bottom, so I can just plug in 6. I can drop my limit and do 6 plus 0, and your answer is 6. So this part is when you can drop your limit because I've gotten rid of the h's, like I've plugged in my value right here. Okay, next one. Here we want to figure out what can we do with this. We want to get rid of that x plus 5 on the bottom. Here you can factor. So a reminder in factoring by groupings. It's probably been a little while. You're going to clump chunks together. Usually you start with the first two and the last two, but not always. And still write our limit. And out of this first chunk, I can factor out an x squared to get x plus 5. And then the goal is to get this to also have an x plus 5. So I can factor out 2 and get x plus 5 here, all over x plus 5. Keep going. And then here we get x squared plus 2, x plus 5, all over x plus 5. Those will cancel. Write your limit out again. We get x squared plus 2. So now I'm not dividing by anything anymore. So now I can plug in the value and we get 25 plus 2 equals 27 for your limit. So this last one here is an absolute value, so it's a little bit different. So we're going to do basically the same idea, but since we have the absolute value, we're going to have to do two chunks, like the positive chunk and the negative chunk, so you have both of them. So we'll do the positive chunk first. You want our limit as x approaches 0 of everything being positive, like this. Write your limit as x approaches 0 again. I'm going to factor out an x, so we get x plus 2 on the top and x on the bottom. Those will cancel. And then we'll get x plus 2 here, which then will give us a limit of 2. So then if we do the negative portion, you're going to start the same way, except you're going to want a negative out front in your x squared plus 2x. So this is going to then jump down and be the same. You can still factor out an x, but you're going to get negative x plus 2, which then will give you negative 2. So since these are not the same, your limit does not exist. If you had gotten like 2 and 2, then it would be the same. Your limit would be 2. But if you get two separate things, then it does not exist. Again, go on Schoology and check the homework because it may be different than this. But that's it.